with the very first, machine learning. So machine learning basically is the field, and you have to forgive me, I move a lot. Machine learning is the field of where basically algorithms are being fed data, and from the data it learns patterns, right, to make prediction, decision, classification. The general model, and this is just a general model, of machine learning is y equal f of x theta, where x would be your data, right? And theta would be the learnable parameter. Remember, when you are giving your, giving the machine learning the data, you need it to learn, right? So you need to, every data has its own feature. We're all familiar with that, right? All right. So like, this is just the component where x is the input feature, f is the general model, and y is what you want to predict. Now, the objective behind any machine learning is, and deep learning is, even when Amna, or when I should say my wife, twisted, plot twist, all right. Plot twist was explaining your main objective is to reduce the theory, to get the most, how to put this, the most parameters that make sense and optimize, right? So that's it. You gotta minimize the loss function, and basically what the loss function is, you're comparing your y with your y hat, which is the target. You're comparing the target with the predicted every time, and then you're updating your parameters, all right? We'll go into details. You have common types of machine learning: supervised, unsupervised reinforcement learning. What are the differences? Supervised basically is when you have labeled data. So if I take a picture of you right now and I start labeling stuff, chair, humans, tables, that is labeled data. Unsupervised is just, I'm not gonna label anything, it's just unlabeled data, right? And two common types of supervised learning is classification, regression. Unsupervised is clustering and dimensional reduction. Reinforcement learning is another field of machine learning, which is very interesting, by the way, where you have an environment and then you have an agent, and the agent learns by interacting with the environment. And this is one of the areas where I introduced quantum reinforcement learning. I shouldn't be exciting you because I wouldn't be explaining it today. All right, so let's take a quick look example into these. This is what a linear regression would look like, right? You see the blue dots are your real data, and the yellow line is the equation that's been learned from the algorithm. So imagine if you have, let's say, the size of a house and into the y-axis, which is the price. So every time the house size increases, the price increases. That's what the yellow line learned from the data, right? So that is linear regression. Nonlinear regression is exactly the same thing, but it's just nonlinear, right? Then you have classification, right? So classification is two classes or more, but for the sake of simplification, I'll just say there are two classes. So let's assume the one on the top, the X's, are students that failed, and the circles are all the students that passed, all right? And then the machine learning learned to segregate them by that dotted line. So whenever I hate that I use the white. Anyways, whenever any data falls in there, the machine learning would be able to say, hey, that person failed or passed. All right, that's the same concept goes for nonlinear classification, where you have inside students that are passed and outside students that are failed. Now, some of you is like, oh, there are some people that passed but still outside. Maybe those students that passed mathematically but actually cheated and being caught. So at all our cases, this is just an example, not the real thing, okay? All right, so moving next, another subfield of machine learning. Oh, by the way, I have to mention that AI, machine learning is a subfield of AI. So deep learning is a subfield of AI, okay? Well, what the deep learning basically is a subfield of machine learning that has to do with neural networks, that has to do with artificial neural networks. And where that came from is the fact that in our brains, there are neurons, and this is how we take decisions, all right? So we went and tried to replicate that using artificial neural network, which is basically deep learning. Now the model, basically, the general model is the same as machine learning, but the difference here, right, is the design of the layers, the input layer, the output layer. Let me explain more. See this diagram? You have an input layer where you'd be giving all your data. Then you have hidden layers, and you have output layer, which gives you the answer. Now, hidden layers, I know it says here 1, 2, 3, but it depends on your architecture, really, right? So I want you to notice, hidden layers is what the calculation happens. I want you to notice how every neuron, by the way, those are the neurons, all right? Every neuron is connected to every other neuron in the previous layer and in the forward layer, right? And between those neurons, there's something called weight and biases. Basically, that's what is learnable parameter. So what happens is, in a short note, you give it the data, it tries to learn the pattern, you have an output, and then you have an optimization function, and then it's fed back again, and so whatnot until it learns. This is what an example layer would look like, where you have the, well, the H would represent, you have the first term, which is the activation function. And what an activation function is, basically activation function is a function that introduces nonlinearity to the whole network. Now everyone knows that data could be, or data could have linear relationships, right? Or nonlinear, right? When it becomes nonlinear, it becomes more complicated. So if we don't have that term, the neural network wouldn't learn anything, right? And then you could see that every weight is being multiplied by the previous input of the layer plus the bias, right? Okay, again, learning objective is basically the same. You want to minimize the loss, and you want to find the theta star, which is the most optimized weights and biases. And yeah. All right, so the common architectures, you have CNN, which I'll cover today. Basically, they are convolutional neural networks that are good with images. You have recurrent neural network, which is using, but it's good with sequential data. I love RNN because I use that a lot in my personal project, the car analyzer. All right, and then you have transformers, which are basically the architecture, the base architecture that built all the large language models we have today, all the one that use ChatGPT and so on, all right? And this is what different architectures of deep learning would look like, right? I want you to notice how there are many different architectures, different names. For example, this generative adversarial neural network could be used for generating images or cleaning noise. And how do you think we came up with all these architectures? That I want you to even notice how the neurons have different colors and they have different, names. How did we come up with all of that? Basically by doing trial and error, researching, building upon. It's what you guys basically do, right? So when you now start your PhD, don't you have to do literature review? It's basically like that. So a lot of these were made because people went and researched. So never underestimate the power of research, all right? Okay. All right. All right.